Okay, Jonathan? Okay, so for notes, we are doing now section 5.5 and section 5.6. We skipped some sections there. We skipped 5.4. We also skipped 5.1. So the stuff you'll be tested on will not include all of chapter 5, okay, at this point. Okay. So chapter 5 or section 5.5 is all about solving problems that look like this. They write it as x plus a equals b. These are numbers, okay? So we're solving the equation. So I'm going to give you an example. If I have x minus 4 equals 7. Now, I want you just to think about that. There's only one answer to this problem. There's only one value that we can put in. When we subtract 4, we will get 7, okay? A lot of you can figure that out right now in your head, okay? But let's just talk about what it means to solve. It means to find the value that makes that equation true.
So it's just basically solve for x?
Yep. This is where we are solving for x or any variable, whatever variable's in there, okay? So can somebody just tell me, looking at this, what would x have to be to make this statement true? Just looking at it, what would x have to be? Can you find that right now? Yes, Marcy.
It would be 3.
Would 3 minus 4 give me 7? That was nice. I know what you were thinking, but that we have to go back and think about what the statement says. Okay, yes,
11?
Jonathan. 11. Okay, so if you actually think about this, x has to be 11. Okay, when we do simple problems, I know some of you can do them in your head. Okay, but I'm going to show you a process that works so that if you can't do it in your head, it's a decimal or a fraction, or it's a big number, you can find out what the answers are. Okay, now how did you find that, Jonathan? What did you actually do?
Well, I know 7 plus 3 is 10, so like I kind of did 4 plus 7.
Okay, you did 4 plus 7, which is a wonderful statement. You know why? Because that's really what you're going to do. Okay, so let's look at this. When we want to solve it algebraically, this is solving it algebraically. Notice he did the opposite operation. If you think about, this is a subtraction sign. He said he added 7 and 11, right? He did the opposite operation, which is adding. It goes back to those addition facts. Remember when you did addition facts? Fact families. 4 plus 7 is 11. 7 plus 4 is 11. 11 minus 4 is 7. 11 minus 7 is 4. Okay, those were fact families. Okay, we are actually doing that same thing here. So when I write it, I'm just going to show you the writing part of it. And I would like you to practice writing it, because when you get to harder problems, I want you to make sure you get it correct. Okay, so x minus 4 equals 7. So what I want to do is, this is a minus 4, right? That's a minus 4. I'm going to add 4 to this side. Let's see why we did that in a minute. And I'm going to add 4 to this side. You know what that does? It keeps both sides of that equation equal. So if I add 4 over here and I add 4 over here, they're still equal. Okay? Why did I add 4? Because what does negative 4 and positive 4 equal? Yes, 0. So if I have x plus 0 equals 7 plus 4, which is 11, do I have to write x plus 0?
No.
I don't, do I? I do not have to write x plus 0 equals 11. I could just write x equals 11, because if I add anything to 0, it's going to be what it was to begin with. So notice we got the answer. This is algebraically. This is doing it algebraically because we know what to do on both sides. And when you get to more complicated problems, these things become very important to realize how to do it. So let's look at a different problem. Again, we're going to do the opposite. So all we're working with is adding and subtracting today. Okay, so we're not going to work on multiplication and division. We're just going to work on adding and subtracting, because that's all we really talked about, was adding and subtracting integers. And that's really what you're doing here. Okay, so if I have 3/4 plus x equals, I'm going to make it 11/4. Okay. Now, some of you might be able to figure that out. What plus 3/4 would give me 11/4? Okay. Somebody want to guess at what that would be? Yes, John.
8/4.
8/4. So
Wouldn't that reduce down to like 1/2 or something? Or no, 2/1 or something.
yeah, it equals to 2, but we're not going to do that right at the moment. Okay. So he's guessing 8/4. Okay. Now you can check that and see if that works, and you know your guess is right. That's the guesstimate one. Okay. So if we look at this right here, we have a positive 3/4. Does everybody agree with that? That is a positive 3/4. We want to zero it out. How do I zero out a positive 3/4? What do I do? How do I make it 0? Yes.
Add -3/4.
Yeah, add the opposite. Add a negative 3/4, which is really subtracting, okay? Because positive 3/4 plus a negative 3/4 or subtracting 3/4, either way makes 0, okay? So what we actually did is we did 0. I do this sometimes for people because we want to do the same thing on both sides. So I'm also going to subtract 3/4 over here. Notice I did the same thing on both sides of the equation. So if you put the little line down for where the equal sign is, you know you're doing it on both sides. This helps because I know sometimes if we put numbers together, you'll think, oh, I got to subtract the opposite. But no, they're on the same side of the equation. We don't do subtracting of the opposite then. Okay, so that gives me 0 plus x equals, my equal sign always goes on the dotted line, and if I take 11 minus 3, I do get 8/4. I don't need to write the 0, we say x is equal to 8/4, which again is what you guessed just looking at it. Okay. Now let's say if I make it a little harder. I'm going to make sure you have that all copied before I go on. I'm going to write the problem a little different this time, but it's really the same thing. Okay. So, here's my problem. The problem is 3.3 is equal to some number minus 2.6. We are trying to find out what is that number that when I subtract 2.6 from it gives me 3.3. Okay. That's not as easy to find right off the top of your head, right? It's not an integer, so sometimes decimals get a little crazier. Okay. Some of you can find it, but I'm trying to get you used to doing the procedure because this will become beneficial as you get harder and harder problems. So some of these look easy and you can do them in your heads. Please don't. Practice doing it, this method, so when we get into harder problems, you know the method. I know for all sorts of people, it's really a temptation with these ones to just do it in your head. Don't, because that makes it harder later, okay? So what we want to do, and this is where, because it's on the opposite side, we want to look for where the x is. When we are looking at the x, we want to get rid of whatever number, so our goal is to get x by itself. We want to get it so it's x plus 0. X plus 0 is our goal. So to get rid of this negative 2.6, what would I do? Because I need to get x by itself. I need to write x plus 0 as my next step. What would I do? It's a negative 2.6, so what am I going to have to do that? Gavin?
I'll make it a positive number.
Yes, we're going to make it positive 2.6, or we're doing the opposite. This is subtraction. The opposite of that is adding. You can think of it as negative and positive. You can think of it as subtraction and addition. It doesn't matter. Okay? But what we are doing is by doing the opposite signs, it gives us 0. But we don't just do it on one side, we also have to do that same thing on the other side. So basically what I've done is I'm adding 2.6 here, I'm adding 2.6 here. You always have to, in an equation, you always have to do the same thing on both sides, or it will not stay equal. Okay, so this gives me x plus 0, which I don't need to write. You'll learn right away that you don't need to write. What I normally do is go like that. Those cancel each other out. And so I have x all by itself. Because positive 2.6 and negative 2.6 are 0. They cross out. They cancel each other. So that means I just add. So we add this, we get 5.9. 5.9 is the number that when I subtract 2.6 from it, I get 3.3. Okay, so my answer to this equation is that x equals 5.9 because 3.3 equal to 5.9 minus 2.6, because my original equation was 3.3 equals x minus 2.6. So instead of x, I write the 3.9 in. If I do my work there, I will have a true statement. Does that make sense there? So that's basically what you're doing when you're adding and subtracting these. Okay. You're just doing the opposite. This, when you're solving an equation like this, you have one answer. Do you notice every time we've done this problem, we have exactly one answer? Okay. On these types of problems, you're going to have exactly one answer. Now, sometimes the answer might be 0, but that's still an answer. So if I gave you a problem like this, which yes, I'm probably going to say you don't really need to do any work, but if I gave you 3 plus x equals 3, okay, I think most of you could guess right now.
0.
It's 0. X equals 0. Okay? But if I subtracted the 3 here and subtracted the 3 here, that would give me x equals 0 also. So both ways, just guessing it or putting it down like that. I'll just tell you, the easiest one to answer is when the answer is 0. Because you can look at it and say 3 plus some number is equal to 3. We know that. That's 0. And that one I wouldn't expect you to show work because you can say that obviously. Okay? Yes?
Is it possible to do like a times and divided by? And then
We are, but that we're not doing yet.
Could you get a remainder in the divided by?
Yes, you can. We'll talk about that when we get there. Okay? We are not doing those yet. We are only adding and subtracting right now because I want you to practice these. Okay? So 5, 6. 5, 5 is all about the equations. 5, 6 is solving inequalities. Now, the difference between solving inequalities and solving equations. This is like x plus 2 equals 9. X equals 7 is my answer. Okay, I get one number as the answer. One exact answer. Okay, that's what we get when we solve an equation. Okay. If we are solving an inequality, we get a range of numbers. Okay, we get a whole bunch of numbers. So let's say we have x plus 2 is greater than 9. Okay, very much the same problem that we have over there with the equation, and we are actually going to solve it very much the same. We are going to still do the opposite, even though it's an inequality sign. Okay, so here I would subtract 2, so I can get x by itself. Subtract 2 here, instead of the equation being where it separates, the inequality is. Okay. That cancels, giving me x here, because a positive 2 and a negative 2 make 0. I don't have to write a 0 down when I'm adding it. Okay. The inequality does not change. 9 minus 2 is 7. So we have values. This is saying that values that are greater than 7 make this inequality true. Okay. What are some values that are greater than 7? Gavin, what's one number that's greater than 7?
8.
8 is greater. What's another greater than 7? Marcy?
10.
10. Okay, what's another number that's greater? Peyton?
Greater than 7?
Yep.
11.
Sure, 11. So we can actually list an infinite amount of them, right? Okay, so this is one way of writing it. It's x is greater than 7. The other way of writing is when we go back and we review kind of our inequalities. You make your number line. Here's 0. Here's 7. We want numbers greater, right? This direction. So we've got what numbers that are greater than. It does not include 7. So remember, it doesn't include 7. So we put an open circle. Okay, if it does not include 7, it's an open circle. So we graph the numbers because it's really hard to say what the answers are because there's actually a whole bunch of answers. So instead of just one number, there's actually an infinite number of answers. And so we put those on a number line to show what numbers. This is much easier to say, oh, it's 8, 9, 10, 11, 7.5, all those numbers that are greater than it. Okay, so that's what we're looking at there. So that's really what 5, 6 is all about. It's just adding. You're doing the same process as with the equals, but you're adding the one step of graphing your final inequality, which we graphed inequalities like this already. We've already graphed them, so we know how to do that. Okay, so let's do another problem. I'm going to have you do one right now. Now I'm going to tell you that might be a little bit harder problem, but go ahead. I'm going to put an equal sign in there really fast. Think about getting x by itself first. What do I have to get rid of? Do that same thing on both sides and find the answer and then graph it. want the graph. Go ahead, do that problem. That's my first step gonna be. What do I want to get rid of? It's by the x,
The minus.
the minus 2.3. So how am I gonna get rid of that? What am I gonna do?
Well, you're adding.
Correct, add 2.3. I heard it whispered over there. So we're gonna add 2.3 on both sides. Now it does a little bit of work on how do I get from negative 1.5 and add 2.3. Going back and doing a little bit of review. You can look at your drawings with the number line.
So you basically gotta go to the left and then reverse and go right.
So you start at negative 1.5 and then you go to the right 2.3. Okay. I heard somebody say something.
Negative 1.5.
It's gonna be what?
It's not 1.5, it's negative.
Yes, it is.
Oh.
It is negative
Whoopsie.
1.5.
That'd be 1.3. Right? I thought it was just 1.5. 2 point, I guess I do have to get the
No,
numbers.
not quite.
1.2. Oh.
No.
1.8 on that.
We'll go through this. Everybody start just by adding 2.3, correct? Okay. Oh, Ezekiel, I think I have some of your stuff. There you go. Okay, I'm going to start up here. Plus 2.3 plus 2.3. This cancels, so x is greater than or equal, but we need to figure out what this is. Okay, I'm going to go over here and draw a little separate diagram. Okay, we're going to start at negative 1.5, which is right here. Negative 1.5. We are going to go to the right 2.3. Is that correct? Okay. So if we're going to go to the, because it says add 2.3, so I want to go 2.3. So I have to go 1.5 to go up here, right? This part is 1.5 to get to 0. Okay. So 1.5 leaves me 0.8 to go farther. Because if I add 1.5 plus 0.8, I get 2.3, which is what I wanted to add it. So I'm right here at 0.8. Okay, does that make sense? That's tricky. I know that's tricky. Okay, but it took 1.5 just to get to 0. So I'm going to give you this little kind of thing. You're actually going to subtract these because you know it's going to take the 1.5 to get to 0. And so when I subtract them, I know how much is left to go the remaining way. So 0.8 remaining. So this is going to be greater than 0.8. So here's this, 0.8 is approximately right here. It's going to be solid because it has an equal, and it's greater than, so it goes that direction. Okay. Okay. Questions on how I got those at that answer? Because I know this can be a little confusing. Again, we started at negative 1.5. We had to go 1.5 to get to 0. Okay, so basically, I had to figure out how much is left. Well, to figure out how much is left from 2.3, I would actually subtract. And so I still have 0.8 left. That way I go a whole 2.3. And so that is where I'm going to be at. Okay. If there's nothing left, like you don't go all the way to 0 because it's not enough, then you're not going to have a positive answer. Okay. But think of how it works, because I have to go 1.5 to get to 0, but I still need to go another 0.8 because otherwise it won't be 2.3. Okay. So that's what we're looking at. So any questions on that? This is where it gets more difficult when you're starting to look at some of these problems with negatives and positive numbers. Okay, that's why we had you practice positive and negative numbers on your addition and subtraction of integers and other numbers, and that were in 5.2 and 5.3. That's where we practiced that. Okay, so